Light surrounds you every second, yet its nature remains one of the deepest mysteries in science. We see it illuminate rooms, bounce off objects, and reach our eyes so we can perceive the world. We measure its speed and declare that it travels 300,000 kilometers every single second, a number repeated in textbooks and classrooms. But what if that statement is incomplete? What if light does not move the way we imagine movement? This video will take you beyond common explanations and explore ideas that challenge everyday intuition. You will learn what scientists mean when they say light travels, why time and space behave differently at extreme speeds, and how modern physics reshapes our understanding of reality. By the end, you will see light not just as something that moves, but as something that reveals the structure of the universe itself. This is not about complicated equations or dense technical jargon. It is about ideas that are simple to grasp but powerful enough to change how you think. We often assume movement is obvious. A car moves because it covers distance. A bird flies because it changes position. But light does not experience time in the way we do. According to relativity, as an object approaches the speed of light, time slows. At the speed of light, time effectively stops. From the perspective of light, there is no journey, no before and after, no ticking clock measuring its passage. It arrives instantly. That single concept forces us to reconsider what movement truly means. If there is no time for something to experience change, can we still say it moves? Or is movement something only observers perceive? These questions are not merely philosophical. They strike at the heart of physics and our understanding of existence. For centuries, humanity believed space and time were separate. Space was the stage, time the ticking clock. Objects moved through space while time marched forward. But modern science shows they are connected. Space and time form a fabric, what we call space-time. Gravity bends this fabric, and objects follow the curves. Light travels along those curves, but from its own perspective, it does not feel the passage of time. Imagine a journey where the destination is reached the instant you begin. No seconds, no minutes, no distance in the traditional sense. That is the paradox of light. We observe it moving because we measure it. We see it cross space and calculate the time it takes. But observation and measurement are not the same as experience. A ruler measures distance, yet the ruler itself does not experience the act of measuring. In a similar way, light can be observed traveling without experiencing travel. This idea reshapes how we think about reality. The universe is not always intuitive. Everyday experience teaches us lessons that apply to normal speeds and familiar objects. But at extremes near the speed of light or in the presence of massive gravity, those lessons change. Time slows, space bends, and concepts we take for granted require revision. That does not mean science contradicts common sense. It means common sense has limits. It evolved for survival, not for understanding black holes or subatomic particles. Science extends our vision beyond those limits. It reveals patterns and principles that are hidden from direct experience. Consider how we once believed the Earth was the center of the universe. Observations seemed to support that idea. The sun rose and set, stars moved across the sky, and everything appeared to revolve around us. But careful study revealed a different truth. The Earth orbits the sun, the universe is vast, and our perspective is limited. In the same way, our understanding of movement and light is evolving. We once thought light required a medium to travel, a substance called the ether. Experiments failed to find it. Physics adapted. The theory of relativity replaced older ideas and explained phenomena with greater accuracy. Light does not need a medium. It propagates through space-time itself. This is not magic. It is mathematics and observation working together. Yet it produces results that feel strange. Time dilation, length contraction, and the constant speed of light challenge intuition. They remind us that reality is deeper than appearances. Light, in a sense, exists outside our ordinary understanding of motion. It is both wave and particle, both energy and information. It behaves differently depending on how we observe it. That dual nature is another puzzle. Waves spread out and interfere, Particles occupy specific locations. Light exhibits both behaviors. Scientists describe this with quantum mechanics, a framework that governs the smallest scales of existence. Quantum theory introduces ideas that seem even stranger than relativity, particles existing in multiple states, probabilities replacing certainty, outcomes influenced by observation. Yet these ideas produce predictions that match experiments with remarkable accuracy. The universe is not obligated to conform to human expectations. It follows rules that we gradually uncover. Light's behavior is one of those rules. It moves as far as we are concerned, but from its own perspective, it does not experience movement. It is bound by the structure of space-time, reaching its destination without experiencing the passage of time. That realization invites humility. We are observers trying to understand a vast and complex cosmos. Each discovery expands knowledge, but also reveals new questions. Why does space-time have the properties it does? What lies beyond our current theories? Can we ever fully comprehend the nature of reality? These questions are part of the scientific journey. They drive curiosity and innovation. They remind us that learning never ends. The mystery of light is one piece of a larger puzzle. It connects to gravity, time, and the origin of the universe itself. By studying light, we study existence. We explore the rules that shape everything around us. If you found this exploration intriguing, if you enjoy uncovering ideas that challenge assumptions, you are in the right place. This channel exists to explain complex concepts in clear and engaging ways. We dive into physics, science, and the mysteries of reality. We ask questions and search for answers. Sometimes those answers are satisfying. Sometimes they lead to even deeper questions. That is the beauty of knowledge. It grows as we seek it. So if you want to understand the universe a little better, if you enjoy thinking about ideas that stretch the imagination, subscribe to the channel. Join our community of curious minds. Like this video if you found it valuable, and share it with others who might enjoy the journey. Together we can explore the wonders of science and uncover truths that shape how we see the world. Welcome, and let's begin. Light does not behave like a car driving down a road, and that simple comparison already begins to show why the idea of movement requires deeper thinking. A car travels because it occupies one position and then another. It requires space to move through and time for the journey to unfold. Without space, there is nowhere to go. Without time, there is no before and after, no sequence of events that defines travel. We observe cars moving because we can measure distance and duration. We see them start at one point and arrive at another. That is movement in the everyday sense. But when we apply the same idea to light, things become less straightforward. Light appears to move because we detect it at different locations over time. A beam of light leaves a source, and later we observe it reaching a destination. From our perspective, it has traveled, yet the nature of that travel is unlike the motion of objects we experience in daily life. It does not roll along a surface or push against air. It propagates through space-time in a way that challenges ordinary intuition. Movement, in the traditional sense, relies on change over time. An object moves because it occupies one place, then another, and the passage of time connects those states. If time were removed from the equation, movement would lose meaning. There would be no sequence of events, no transition from past to future. This is where light becomes unique. According to modern physics, time behaves differently for objects approaching the speed of light. Relativity tells us that as speed increases, time slows. This phenomenon is known as time dilation. It is not speculation but a measurable effect confirmed by experiments. Clocks on fast-moving objects tick more slowly than clocks at rest. The difference is small at everyday speeds, but it becomes significant as velocity approaches the speed of light. If an object could reach the speed of light, time would effectively stop from its perspective. That statement is difficult to grasp because it contradicts common experience. We live in a world where time feels constant. Seconds pass, hours turn into days, and life unfolds in a steady sequence. But physics reveals that time is not absolute. It depends on motion and gravity. The faster something moves, the slower time passes for it relative to an observer. At the speed of light, time dilation reaches an extreme limit. No time passes at all. If no time passes, there is no opportunity for experience. There is no moment of departure and no moment of arrival. From the perspective of light, travel is instantaneous. It reaches its destination without perceiving the journey. This idea forces a reconsideration of what movement truly means. When we say something moves, we usually imply that it experiences change over time. A runner moves because they start at one point and finish at another. Their body goes through a sequence of positions, and time allows that sequence to exist. Light, however, does not experience time in the same way. It exists in a state where the journey and the destination are effectively simultaneous. We measure light's movement because we observe effects. A flash of light appears at one location and later at another. Instruments detect its presence and allow us to calculate speed. Those calculations show that light travels at a constant rate in a vacuum. This speed is a fundamental property of the universe. It does not change based on the observer's motion. Whether we approach light or move away from it, its speed remains the same. That constancy is another clue about its nature. Objects with mass cannot reach the speed of light. As they accelerate, they require more and more energy. The closer they get to light speed, the greater the energy demand becomes. At the limit, infinite energy would be required to surpass it. Since infinite energy is impossible, massive objects cannot reach or exceed light speed. Light itself, however, has no rest mass. It exists as electromagnetic energy. Because it lacks mass, it can travel at the universal speed limit. That speed is not arbitrary. It emerges from the structure of space-time and the laws governing energy and motion. Relativity describes how space and time are connected. They are not separate entities but parts of a unified framework. Events occur in space-time, and motion is described relative to that framework. When an object moves, it changes position in space as time progresses. But at the speed of light, time does not progress in the usual sense. The relationship between space and time shifts in a way that eliminates the experience of duration. From light's perspective, there is no journey, there is only arrival. This is the core of the idea that light does not move in the traditional sense. We perceive movement because we measure changes. A detector registers light at one location and later at another. That sequence suggests travel, yet from the viewpoint of the light itself, there is no sequence. There is no period of waiting or progression. It exists in a state where distance and time collapse into a single event. That concept challenges intuition because human experience is built around time. We remember the past, act in the present, and anticipate the future. These distinctions shape our understanding of reality. Movement fits within that framework. Things change, and time allows change to be meaningful. But physics reveals that the universe operates on principles that extend beyond everyday perception. Light is a prime example. It behaves in ways that differ from objects with mass. It moves through space, yet it does not experience time. It arrives without undergoing a journey. This does not mean that light is stationary. It propagates and interacts with matter. It illuminates surfaces and enables vision. Its effects are observable and measurable. But the experience of movement, as we understand it, does not apply in the same way. From our perspective, light travels. From its perspective, there is no passage of time to define travel. That distinction leads to a deeper question about movement itself. If movement requires time, and if time does not apply to light in the usual sense, can we truly say that light moves, or is movement a concept tied to observation rather than absolute experience? We detect light in motion because we observe it at different points. Instruments record its arrival and allow us to calculate speed, but those measurements describe behavior, not subjective experience. Light does not think or perceive. It follows physical laws. The idea that it reaches its destination instantly is not mystical. It arises from the mathematics of relativity and the structure of space-time. Understanding this requires separating intuition from scientific description. Everyday language suggests that movement always involves a journey. Something starts, travels, and ends. That framework works for objects at ordinary speeds. It describes cars, people, and planets. But at extreme velocities, especially the speed of light, the rules change. Time dilation removes the experience of duration. Without duration, the concept of journey loses meaning. This does not diminish the importance of light. On the contrary, it highlights its significance. Light connects us to the universe. It carries information, enables vision, and reveals cosmic structures. Through light, we observe distant stars and galaxies. We study the history of the cosmos by analyzing the radiation that reaches Earth. Light is both a messenger and a fundamental component of reality. Its behavior teaches us about space, time, and the nature of existence. The idea that light does not experience movement challenges assumptions, but also enriches understanding. Science often reveals truths that differ from initial impressions. The Earth once seemed flat and stationary. Observations suggested otherwise, and knowledge evolved. In a similar way, our understanding of movement and time continues to develop. Relativity transformed physics by showing that space and time are interconnected. It demonstrated that measurements depend on the observer's frame of reference. There is no single perspective that captures every aspect of reality. Light exemplifies this principle. It behaves consistently across reference frames, yet its experience of time differs from ours. That difference does not make it mysterious in a supernatural sense. It reflects the laws governing the universe. By studying those laws, we gain insight into how reality functions. The question of whether light moves leads to broader contemplation. Movement is not only a physical concept, but also a philosophical one. It relates to change, perception, and the passage of time. Light exists at the intersection of these ideas. It changes location, yet it does not experience time as we do. It moves from our viewpoint, but from its own there is no journey. This understanding does not require abandoning common sense. It requires expanding it. Science often introduces ideas that seem counterintuitive because they extend beyond everyday experience. Relativity and quantum mechanics are examples. They describe phenomena that operate on scales and conditions unfamiliar to human intuition, yet they provide accurate explanations and predictions. Light's behavior fits within that framework. It moves through space, interacts with matter, and obeys physical laws, but its relationship with time distinguishes it from objects that experience duration. That distinction reshapes the meaning of movement. It shows that travel is not always defined by subjective experience. Measurement and observation reveal patterns that transcend intuition. The universe operates according to principles that science continues to uncover. Light is one of those principles. It illuminates the world and the cosmos, both literally and figuratively. By studying it, we learn about space, time, and the structure of reality. The question of movement becomes a gateway to deeper knowledge. It encourages curiosity and exploration. It reminds us that understanding is a journey, even if light itself does not experience one. Light shapes our universe in ways we often take for granted. It allows us to see, to explore, and to understand the world around us. Without it, life as we know it would not exist. Yet despite all our progress in science, its true nature still carries layers of mystery. We measure it, study it, and use it every single day. But the deeper we go, the more questions appear. That is the beauty of knowledge. It does not end. Each discovery becomes a stepping stone to something greater. Light teaches us that reality is richer than our assumptions, and that understanding the universe is a journey, not a final destination. If you enjoyed this video and learned something new, subscribe to the channel so you never miss future explorations. Like this video if it made you think differently, and share it with others who enjoy uncovering the secrets of science. Together we can keep searching, learning, and expanding our understanding of the world. Thank you for watching, and I will see you in the next video.